Hi. So in this episode, we will discuss a new solution concept called perfect Bayesian equilibrium. So that'll be a simpler solution concept compared to the previous one, which was the sequential equilibrium, right? So in the previous sequential equilibrium, we need to really to find first to satisfy the sequential rationality and the second this consistency, right? So normally when we're satisfying the consistency, then we need to find the limits, and so that the Bayesian the Bayes rule works everywhere, right? So here in this simpler solution concept called perfect Bayesian equilibrium, so we still have the sequential rationality, but instead of consistency, we simply say that we don't need that much of the requirement for that. So here we simply only need to derive the belief using the Bayes rule. We say that whenever possible. Okay, and now let's have a closer look on this definition. So we say that an assessment is a perfect Bayesian equilibrium with the sigma and mu. So this sigma is still a behavioral strategy, and this mu will be a belief system. So sigma should be a strategy profile, right? So if this assessment, it is first sequentially rational, so that's similar as before. So the second becomes that if this belief system, it is derived from the strategy profile sigma using the Bayes rule whenever it is possible. Okay, so whenever possible, it means that whenever the denominator of the Bayes rule is not zero. Okay, that doesn't equal zero. So that'll be much simpler than the requirement for the sequential equilibrium for the consistency, right? Good. So here, so and we could already see that the sequential equilibrium would be a subset, or it is a sort of a refinement of a perfect Bayesian equilibrium, right? So it has a stronger requirement. Okay, so here sometimes when we normally we need to specify all those sort of so-called off-path beliefs, or the beliefs that are out of the equilibrium path. So it means that if when we're having this equilibrium path, so it means that the players they are reaching the terminal node with some strategy profile, and with that on-path belief. So here for the off-path belief is that some nodes that cannot be reached in the equilibrium, right? So that's why we're calling this as off-path belief. But normally we need to specify those off-path beliefs, although they can be just arbitrary. Okay, good. So now let's take a look on the example on the previous video where we discussed the Sultan's horse. So we could recall that. So that is written on the below. So here in the sequential equilibrium, we said that a sequential equilibrium could be there are several of those, and they could be such that the behavior for player one in the initial node and to play C has probability of 1, and for player 2 plays little c after the history of big C, and that'll be also probability 1. Okay, and for the player, so we were talking about this, right? So this. So for player three's behavior strategy, then after reaching this information set, then the player three plays this L with the probability of less than a quarter. And the corresponding, the consistent belief that player three has is to believe that the information set is reached by this history D, capital D, with the probability of one third. Okay, so here, how to generalize this to the perfect Bayesian equilibrium? Okay, so we could simply consider something as follows. Let's say if we let the probability, if we and it turns out that all those equilibria that have the belief for the player three to believe that if the probability of reaching this information set, the probability of having this history with capital D. And if that would be something less than 1/3, as we write here, if that's so, then in this case, player 3, of course, plays R. So we have this beta to be 0, beta 3 for this information set. To play L would be 0, right? Because player 3 is playing R in this case. And we could verify that satisfies the sequential rationality for player 1 and 2, because those other two players, they don't have any incentive to come into this information set. Okay, in this case, they will get 0. Okay, good. So, and all those beliefs that are less than thirds, so that all those equilibria, they are perfect Bayesian equilibrium. Okay, and those all those beliefs, they satisfy these requirements. So those are all the off-path beliefs. Okay, good. So here, so there are several of those, right? So if we, and you could always verify that if we have something like if the player 3 is believing that this probability maybe is greater than 1/3 for playing for the history D, then this would violate the sequential rationality. Okay, and we could simply have a little look for this from this game tree, right? Because those would be the payoff with 3s, and those be the payoff with 1s, right? Good. So the analysis should follow from our previous videos. Okay, good. So, and again, we could see that those perfect Bayesian equilibrium will be kind of more general solution concept, but the sequential equilibrium would require would have a higher requirement for that. Sorry, so that would be a subset of the PBE. Okay, good. So now let's move on to another example, which is given by Michael Spence in 1973 with his very famous paper called Drop Market Signaling. So in this signaling model, so essentially there are two players, okay? So there's a worker, okay, and the worker could be either high type or low type. So this type, this theta, denotes the type, and that would simply represent the productivity. Okay, so those would be essentially the same thing in this model. And here the education level for the worker could be either high or low. So we use EH or EL. And of course, the education is not free. So this signaling model is not cheap talk. It is a costly signal, right? So the worker essentially needs to pay for the education. So the cost of education here would be the C function, and the inputs are the education and the type. Okay, so we have some very basic assumptions regarding this function. So we say that if the C is increasing in the education, of course, if you want to obtain more education, then you need to pay more. That's that makes a lot of sense. And let's say that, but the second order derivative would be less than or equal to 0. So here we simply assume that there's a diminishing marginal effect on that, right? So when you reach a really high level of the education, then to obtain even higher than that, something higher than that, then you might not pay too much on that, right? So, and something more is to have is that this cost is decreasing in the type. Okay, so if you are high type, then you don't need to pay that much, and we have another cross derivative here, that is the second order derivative of this cost function regarding the theta and the type and education together, and this would be negative. So this would be simply meaning that for this change of the for the change of the cost in terms of the different level of education, and that would be we have that change to be negative regarding the type, right? And that also makes sense. Good. So, and here to be more specific, we simply let this cost function for the education to be something as this. So we simply use the education divided by this type. Okay, good. So that's worker. And we have some setups for the firms as well. So firm simply the action for the firm would be just this wage, right? So firm sets some wage, and how to set this wage would be very important in this case, right? So this wage is just a function w, and that would be a function of e. So and we already said that this e it also represents the productivity. So that will be related to the revenue of the firm, right, or the profit. Okay, so and here this mu of e, and that is simply the belief of the theta h. Okay, so we have this probability of mu e to be the probability of this firm is believing that this person, this worker is with the with type H. Okay, good. And we also have a prior belief, which we could use mu naught to denote for that. Okay, which is the prior belief for this theta H. Good. So, and how about the payoffs? So the payoff for the firm first. So that would be simply the profit of this firm. That would be the productivity minus the wage. Okay, as we mentioned, so the productivity would be simply those thetas, and this is the expectation of the productivity, right? Because we have different beliefs for that. We have distribution of that, and here the wage would be simply this wage function. Okay, so and here we consider a fully competitive market where this profit equals to zero for the firm. So here we simply could equal this wage to this previous term, right? And that gives us the following expression. Good. So here, how about the workers' payoff? So we simply let the workers' payoff to be the workers' sort of the profit or the revenue, right? So the worker simply takes this wage and minus the cost from the education, right? Good. So, and in this game, we could find two kinds of different equilibrium, and those are separating equilibrium and pooling equilibrium. Okay, so in separating equilibrium here, that would be a ideal equilibrium for the firm. In this case, the firm could really distinguish which is who is the high type or who is the low type. So here we have all those details, and later we'll also mention another kind of equilibrium which is called pooling equilibrium. So in that one, the firm cannot really distinguish between different types of workers, and the firm has to set the same wage for different kinds of workers, and they take the same level of education. Okay, so let's first discuss the separating equilibrium. Okay, and there are multiple of those. So so in this case, in separating equilibrium, theta h would choose EH, and theta L would choose EL. Okay, and the belief system would be that the probability of having theta h, so that is denoted by this mu EH. Okay, so given that education is high, so mu of that would be 1. So here it means that the firm believes that the probability of having this theta h will be 1 after observing that the level of the education will be high. Okay, and correspondingly this would be 0. Good. So and ideally the wage level would be also be different, right? So if with high level education, then the wage then the firm gives a high wage equals to this theta h, and if the education is low, then gives HL, theta L. Okay. All right. So here we also have some conditions quite similar to the ones that we had before in the screening or mechanism design problem. So it asks that there's no agent who could be able to mimic each other, right? So here, the firm could really distinguish from those two different kinds of types. So here we have the first, that the high type doesn't have any incentive to mimic the low type in the separating equilibrium, and likewise for the low type. Okay. So here the this would be the high type if reporting truthfully, and this would be the high type if reporting as the low type. Okay. So this would be the taking the low type's education and getting low type's wage, and this would be similar for the other case for the low type. Okay, good. So here we have little pictures for for showing all those results that we had before, and to illustrate the idea behind those separating equilibria. So these red and blue lines are just the difference curves for the utilities for the high or low types. Okay. Good. So the blue one is for the high type, and the red one is for the low type. So here we simply have this some level, just some level of the utility, right? So we don't have to worry about what is the level of the utility exactly, but here we simply need the comparison between those two different kinds of utility functions. So those are not exactly the utility functions, but those two curves represent some certain level of the utilities. Okay. Good. So, and the reason why we have a flatter line for the high type is that if we know this from the high type's utility function, right? So if with higher level of education, then this increase of the wage doesn't have to be that much, right? So that means that the high type has pretty it doesn't have a very high level of the wage if E becomes bigger, right? So it means that this blue line for high type is flatter than the red one. Okay, good. So what the sequential equilibrium is in this case, so here this firm could essentially have some wage function, which is shown in this picture, in this green line, green curve, which is the wage function. So if the wage is something like this, and it could really distinguish between two different types of the worker. Okay, so here what the high type in blue would choose this point, right? So the high type would choose this EH and to get this theta H, and the low type would choose this EL, which is 0, and to get this theta L. So the reason is because given this wage function, and both two types, they cannot really choose other options. This is simply because that those are the indifference curves, and the only direction that both agents are better off is to move those two lines upwards or to the left, right? So if we move those downwards or to the right, then this will lower the both utilities of the two types, right? So here this green curve would essentially distinguish between those two different types. Okay, and we could directly see that if we move this red or blue curve, either of those down, then either of those types would have a strictly lower expected utility than this case. Okay, good. So, and we want to ask that how is there a range for us to have this certain kind of the separating equilibrium if there is some range for this education level. Okay, and it turns out yes, we could have something for that. So if we simply move this, so disregarding this green curve for now, so let's see if we move move the indifference curve for the high type, if we move down to this picture, okay, it is here. And then what they have intersection here, and what the firm could do is to have this green wedge function here, okay, and that could still work to distinguish the high type, and that would be so high type would be essentially choosing this upper bar, and the low type still remain the same as before, okay, choosing 0. And similarly, we could also move that blue line upwards, and it goes here, so they intersect to each other on the top, okay. So here essentially this could still distinguish the two different kinds of workers, right, with this green wedge function. Okay, good. So those are the separating equilibria, and we mentioned that there's also a pooling equilibrium, right? So in the pooling equilibrium simply means that both types, they have the same level of education, and they have the same level of wage, okay, and the firm really cannot really distinguish from them. So here we could obtain that pooling equilibrium by simply having this wage function, this green curve, right in the on the intersection of those two lines, right? So we have this intersection here. So at the start, both two types, they have the same level of education, EH equals EL equals E star. And for the belief of the firm would be such that this mu of E star would be just the prior, that the theta would be theta H, okay, as we mentioned in the beginning. Good. So now we have shown all those different equilibria in this job market signaling model. And that'll be a very helpful example for us to further understand the perfect Bayesian equilibrium. Okay, good.